Hello everyone. My name is Spencer Allingham, and I'm the Regional Vice President and Technical Director at Conducive Technologies for Europe, Middle East, and Africa. Hopefully, you can all hear me okay and see my screen. Today, I'd like to introduce you to the Velocity software that you can use to speed up your SQL servers and other types of servers as well, without having to reboot machines and without any SQL code changes being necessary. And if you have any questions as I'm going through, please do feel free to put them into the questions box in the webinar software, and I'll do my very best to answer all of them in a Q&A session at the end. I hope that's okay. Right. So, to illustrate why you might want to consider downloading and installing the Velocity software onto your SQL servers, I ran some lab tests using HammerDB to generate an online transaction processing type workload with and without Velocity installed. Firstly, using SSD storage, and then using older spinning disk storage. And as you can see from the metrics recorded by HammerDB, over SSD storage, there was about a 30% improvement in the number of SQL transactions that could be processed per minute. And this was backed up by Windows Performance Monitor metrics that showed a 28% improvement in transactions per second. When running the tests again using spinning hard drive storage, there was around 100% improvement. Now, either way, this is great news for SQL DBAs who care about the performance of the databases underpinning their business-critical applications. Whether running SQL in a physical or a virtualized environment, most SQL DBAs would welcome faster storage at a reasonable price. And Conducive's Velocity software is designed to provide exactly that, but using the storage hardware that you already own. It doesn't matter if you have direct attached disks, or if you're running a tiered SAN, have a tray of SSD storage, or are fortunate enough to have an all-flash array. That storage layer can be a limiting factor to your SQL database's productivity. The Velocity software reduces the amount of storage I/O traffic that has to go out and be processed by the disk storage layer, and streamlines or optimizes the data which does still have to go out to disk. The net result is that SQL can get more transactions completed in the same amount of time, quite simply because on average, it's not having to wait so much on the storage before being able to get on with its next transaction. And the Velocity software can be downloaded and installed without any disruption whatsoever to live SQL servers. As I said before, no SQL code changes are required and no reboots. Just simply install, and typically you'll start seeing positive results in just a few minutes. And before we take a more in-depth look at that, I'd like to briefly mention that the Velocity software was awarded the Microsoft SQL Server I/O Reliability Certification, which is quite a mouthful. But this basically means that whilst providing faster storage access, Velocity didn't adversely affect the required and recommended behaviors that an I/O subsystem must provide for SQL, as defined by Microsoft themselves. Now, most SQL DBAs are familiar with why split pages are bad for performance. If you've got room and your update or insert doesn't require a split, well, this is pretty fast because SQL is just updating one page and then writing it out to disk and, of course, to the transaction log. But if the updated or inserted row doesn't fit, SQL needs to allocate a new page, move about half of the rows to the new page, and then write both pages to disk and to the transaction log. In addition, the pages and all the indexes that point to the data pages, well, they need to be updated too. So as an example, let's say that your table had one clustered index and 4 non-clustered indexes. That would mean at least 7 pages would need to be updated. You'd have 1 for the clustered index structure, 4 for the non-clustered indexes, and 2 in the data pages in the clustered index. So this page split would result in a minimum of 7 times the I/O as an insert or update that didn't require a page split. Now, each I/O that takes place takes a measurable amount of time and resource to process. And the same is true when the Windows file system splits data as it writes out to the logical NTFS volume, and that can have significant performance ramifications too. And this is why SQL DBAs format volumes to be used by SQL with a 64 kilobyte cluster size rather than leaving the NTFS default of just 4 kilobytes. It helps to avoid split I/O situations when writing to disk and keeps performance losing file fragmentation from building up so quickly. It doesn't fix the problem though. As your NTFS file systems mature over time and files are created, extended, and deleted, the free space on the NTFS volume will become more and more fragmented into smaller and smaller free space extents, increasing the likelihood of those split I/O situations when writing. And each time your write is split in this way, the data is being sent out to disk in separate I/O packets and, more importantly, at a slower data transfer rate. And like split pages in SQL, each storage I/O takes a measurable amount of time and resource to process. So in the real world, a gigabyte of storage I/O traffic that should be written in, let's say, 2,000 or 3,000 I/Os could now be taking 30,000 or 40,000 I/Os to complete to process the same amount of data. And we call the performance penalty that these split I/O situations cause the Windows I/O tax, as in a tax on your performance due to split I/Os. Now, in a virtualized environment, this performance penalty can be amplified by something called the I/O blender effect. And what's happening here is that you have small fractured I/O packets coming from the virtual machines, and as they pass through the physical host, as they pass through that hypervisor, the hypervisor mixes these I/O streams together, causing a randomization effect. So basically, what comes out between the physical host hypervisor and the disk storage controller is now a chaotic mess of small, fractured, and now very randomized I/O streams that by the time they hit the storage controller couldn't be less storage friendly. It means that the storage controller is only receiving data in very small packets at a time, so it now only has the opportunity to create very small stripes across its media, and that means many more storage level operations than if the data hadn't been split as it was being written all the way up at that NTFS layer. Now, velocity helps Windows avoid or prevent most of the excess, unnecessary, performance-losing split I/O traffic and replaces it with far fewer storage I/O packets, each one carrying a larger payload of data. And this makes the movement of data between server and storage more efficient and provides faster data transfer rates and a greater amount of data throughput per second, much like avoiding page splits wherever possible. And it allows the disk storage to store the data using far fewer storage level operations. So it's much better. Velocity will also help create those nice large free space extents quietly and automatically in the background, using only otherwise idle compute resources to make it easier for the Windows write driver to write into. Now, think for a moment of a busy motorway at rush hour. Imagine that you've got lots of cars sitting bumper to bumper with one person in each car, and none of them are getting anywhere very quickly. Imagine the misery on their faces. Now, imagine that each car on the motorway is a storage I/O packet, and each person in each car is your data. What Velocity is in effect doing is taking all of the people out of the cars and placing them in buses or coaches and removing all of the cars from the motorway and getting rid of all of that congestion so that now all the people or your data can now flow to their destination in a much more efficient manner. I hope that makes sense as an analogy, but really that's only half of the story. Velocity also introduces a RAM caching technique into the Windows operating system that further reduces the read IO traffic that the backend storage has to deal with. The performance benefits of that are in addition to SQL's own buffering and any caching natively provided by the Windows OS. And really, this is how we could get 30% more SQL transactions done in the same amount of time during that testing that I mentioned before. Quite simply, SQL could get more work done in the same amount of time because it wasn't having to wait so much on that disk storage layer before being able to get on with its next transaction, and simply because RAM is faster than disk storage. Oh, and it absolutely works with both physical and virtualized SQL servers and in the cloud too. So if you're running a SQL server in Microsoft Azure or AWS, you can absolutely use this software as well. Storage IO reduction, optimization, and RAM caching represent a significant reduction in workload that has to be processed by the backend storage. Now, on average, 30 to 50% less. And this is not only true of SQL Server's storage traffic, but also other workload types too, if they're running inside a Windows OS. So in this example on the screen, let's say that the first VM is hosting SQL, and the second is hosting the application that interfaces with SQL, and the other two VMs are hosting busy file servers, and they're all sharing that same backend storage. You might have a situation where the traffic from the file servers are taxing the performance of SQL by keeping the storage layer busy. So SQL isn't necessarily the cause of the disk storage being slow, but it would likely be affected by the increased disk IO queue depths and latency caused by the busy workloads on the file servers. So my recommendation would be to install the Velocity software on all Windows machines sharing that same backend storage. That way, from the point of view of the storage, it's now simply doing the least amount of work, regardless of which VM is generating the most storage traffic at any given time. Now, at this point, some of you might be thinking, yes, but SQL is already using most of the available memory in the machine. How can you possibly create a RAM cache? And it's true that if SQL is left uncapped, there probably wouldn't be enough RAM for conducive software to create a cache with effectively. We've intentionally designed our software so that it can't compete for system resources with anything else that's running on a machine, basically so that we can never be the cause of a memory starvation situation. Our software would only use some of the free available physical memory that isn't being used by anything else, and it will dynamically size its cache, handing RAM back to Windows if other processes or applications need it. So for best results, my recommendation is to cap the amount of RAM that SQL takes for its own form of caching or buffering. On busy database servers, if you can leave 16 gigabytes of RAM free, you'd have a Velocity cache size that would be big enough to really make that machine's performance fly in most cases. And if you can't spare 16 gig, leave 8 gig. And if you can't afford 8 gig, leave 4 gig free. Even that is enough to make a difference. But if you go much smaller than that, the cache size would probably be a bit too small, and any performance improvements that you would see would be limited. I hope that makes sense. You might also be thinking that SQL's buffering, well, actually, it's good enough. So how does Velocity's caching complement this? And at a basic level, SQL's cache does do a pretty good job. And whilst that does have a positive impact on performance, Velocity's RAM caching is designed to eliminate the type of storage I/O traffic that tends to slow the storage down the most. And whilst that tends to be smaller, more random read I/O traffic, actually it's not always the case. So Velocity uses a very lightweight storage filter driver to gather telemetry for machine learning. And this AI allows the software to learn useful things like, what is the main application in use on a machine? Is it SQL? Is it something else? What type of files are being accessed? And what type of storage I/O streams are being generated? And at what times of the day, the week, the month, the quarter? So it can be very intelligent about what the hot blocks of data are that need to be in the RAM cache, and more importantly, when. It can also use that same telemetry to figure out how best to size the storage I/O packets to give the main application the best performance. And then if the way you use that machine changes over time, Velocity will automatically adapt to those changes without you having to reconfigure or tweak any settings. It's very set it and forget it. Validating results is usually pretty easy. First of all, you could simply measure the amount of SQL transactions being done each day to see if they increase. Some customers see reports that they generate take less time to produce, or SQL imports take less time, batch jobs complete more quickly. We've even had some customers even done a simple stopwatch test to measure record retrieval times. I know that's a bit old school and a bit analog, but if nothing else, it shows that the time difference and the time saving that you can make can actually be measured with a stopwatch. However, Velocity itself comes with very transparent reporting that will show you exactly how much storage I/O traffic it's been able to eliminate from having to go out to that disk storage layer. You can see what percentage of the reads and writes are being eliminated, and it will show you how much storage time is being saved or freed up by the storage not having to process that eliminated I/O. Now, if you're using thin provisioned storage in your virtualized environment, or even down at the storage layer, Velocity can help you reclaim space and manage that. So if you're using thin provisioned VMDK files, for example, in VMware, it can automatically zero out free space for you so that you don't have to wait for hours for something like an SDelete pass to complete. If you're thin provisioning down at the storage layer, maybe you've got a NetApp filer or an HP 3-pass SAN or something like that that uses thin provisioning there, it can also send SCSI unmap commands down to the storage controller and say, hey, storage controller, these blocks, they're no longer needed. You can add them back to the available pool. And that also works with virtual volumes, or vvols, in VMware as well. If your VMs are provisioned with dynamically allocated RAM instead of a fixed amount of RAM, such that the hypervisor can borrow some back to reallocate to some other VM, for best results, it's important to make sure that you reserve enough RAM in your SQL virtual machines configuration for both SQL and Velocity. Otherwise, too much RAM in the VM will become driver locked by the hypervisor's ballooning driver, and that might mean that Velocity might not get enough RAM to cache with effectively. Remember, Velocity is the first thing which will relinquish memory back. So if you make sure that you've got enough RAM to cache with effectively, you'll get best results. If you're using a fixed amount of RAM on your SQL VM, that's not an issue. You don't need to worry about that. Now, these are just some of the case studies that you can access on our website at conducive.com. Very recommended if you want a bit of light bedtime reading, perhaps. As an example, though, Bell Mobility on the bottom left, they're a telecoms company in Canada, and they saw the Velocity software reduce the storage I/O traffic to their SAN by 61%. 61%, that's a massive storage I/O traffic reduction. I mean, that's huge. And this gave them SQL report queries that were 3 times faster with no additional hardware required. All they had to do was simply install the software on their machines, which, as I mentioned earlier, is completely non-disruptive. There are no SQL code changes required, no reboots required, and zero disruption to the live running workloads, and arguably more importantly, no disruption to the users. So firstly, I would encourage you to share what you've learned in this session with colleagues. See what they have to say about this. Maybe some friends or colleagues in the IT industry are already using this software. The simplest and really the best way to test the Velocity software, though, is really to try it for yourself with your real world workloads. I don't want you to take my word for any of this. I really want you to try it for yourself and see what we can do for you. And everybody who's attending today will receive a full copy of the software from Conducive directly, worth about £400 or 450 in euros. Make sure you follow the best practice tips for best results, and really ensure you leave at least 4 gig of RAM free to cache with. You can also try the software on all of your machines at once, which really is the preferred way of testing it, with the 30-day trialware version that you can download right now from conducive.com/try. And if you want any assistance with setting that up, configuring it for best results, please feel free to get in touch with an engineer like myself. My contact details are on the screen here. My email address is srsemir@conducive.com, and my phone number is there. You're very welcome to request help with the trialware or validating results and testing methodologies. Be very happy to help you out. And also, you can share your dashboard report data that the software produces, again, with somebody like myself, and get additional analysis. And we'll even produce a written engineer's report for you. So if your organization would or could benefit from faster storage at a reasonable price using the storage hardware that you already own, I would urge you, please give it a try. As I mentioned before, you're not going to disrupt any live running workloads. You don't have to make any SQL code changes, and really the whole download and installation is very quick and easy. It won't take more than a few minutes, and it's pretty much a next finish type install. Use the software to not only identify those servers that cause storage IO issues and slows, but fix those issues at the same time and get faster SQL servers. So I do hope that's been interesting, and I hope I haven't waffled on too much. Let's see if we have any questions that have come through. There's usually a few. Oh, let's see if I can make that a bit wider so I can see who sent the question. Okay. Okay, so Anthony says, do you support Nutanix AHV? We certainly do support Nutanix storage. You'll have to forgive me, I'm not familiar with AHV. So what I'm going to do, Anthony, is check into that offline. I will find out what type of solution that is, and once I do that, I'll be better placed to be able to advise you on that. Sorry, I'm not familiar with the AHV portion, but I will find out. Senku says, how about the uninstall? Is it also unintrusive? Absolutely, yes. You can install and uninstall with no reboots, no disruption. You can use our own uninstaller, or just simply use control panel add remove programs to do the uninstall as well. And Botta says, hello, is it compatible with TDE also? TDE. Botta, forgive me, I'm not familiar with that algorithm. I will have to check that out as well and get back to you afterwards. We have servers with Postgres and Oracle databases. Interoperability with those, that's absolutely fine. In fact, we have quite a lot of customers running Oracle and some with Postgres as well. Absolutely fine. In fact, I think we even have a case study on here for Oracle. Here we go, Suncoke Energy. So it's an energy company. They got 53% reduction in storage I/O traffic, and that gave them greater throughput on specifically their Oracle workloads. So I hope that answers that. Absolutely, we can. Now, Lynn says, can it work with Linux VMs, BGFS file systems? Now, this isn't going to be the answer you want, but I'm afraid not. This is a Windows-only product. We don't have the software on the shelves today to install onto Linux machines. That being said, if you have a mixture of Windows and Linux virtual machines that are sharing the same backend storage, and you install this software onto the Windows part of the estate, it will reduce the storage I/O traffic coming out from those Windows machines to that shared storage, typically on average somewhere between 30 and 50%. So what that's doing is reducing storage I/O queue depths, reducing latency, and handing storage I/O headroom back to the environment. And those Linux machines, if they're sharing that same storage, they'll be able to take advantage of that extra I/O headroom that's being handed back as well. So even though we're not installing the software directly on them, they should be able to still get some benefit. If you're only running Linux VMs, then I'm afraid we're not going to be able to help, unless perhaps you're using, instead of VMware, you're using a Windows physical server with a Hyper-V role, and we could install it down at that layer. But if that's the case, then get in touch with me and I'll help you set that up, and we should be able to help. So I hope that answers the question. Not specifically for Linux, just Windows. Okay, Baptiste has helped me out here. So TDEs, transparent data encryption. Yes, it is absolutely fine with that. And the reason for that is that we are not bypassing the Windows write driver in any way. When data is being written, it is still the standard Windows write driver creating a standard NTFS I/O packet and sending it on down to the storage. We're not trying to do anything clever like dedupe on the fly or compression. We're simply sitting above the Windows write driver as a storage filter driver and adding an extra layer of intelligence so that the Windows write driver then makes better choices about where to write that data on the NTFS volume in order to not split that data up or split it up the least, so that you get these fewer but larger storage IOs that are carrying a bigger payload of data on down to the storage. So we're not trying to temporarily buffer the data anywhere or hold it up in the data path. We're simply allowing Windows to make better choices about how it creates storage I/O traffic so that everything below that point in the stack, all the way down to the SAN or whatever storage you have at the back end, benefits by dealing with reduced I/O, and the I/O it does have to deal with is in these larger chunks of data that can be dealt with more contiguously and rather than having that same amount of data split up and dealt with in lots of tiny packets. So I hope that helps. It will be fine with transparent data encryption because we're not bypassing the way that Windows creates and deals with storage traffic. We're just adding that extra layer of intelligence so that it can do it better. So Lynn says, excellent. You're very welcome. Alex says, how can this software work for Azure managed instances? Okay, now if you're running effectively virtual machines in Azure and those virtual machines have a Windows operating system, you can install the software. If you're using sort of appliances or software as a service in Azure, then there's no OS that you have the access to install the software, so we won't be able to help there. But we can certainly help if you have access to the Windows operating system running in effectively a VM in Azure, you can install the software and it will provide you benefit. So Alex, I don't know if that's the answer you were hoping for. Hopefully it is. Let's see. Lynn says, thanks. That was about the Linux question. So I think that's all the questions that I can see. I'll just double check. Looks like a couple of people were having problem with the audio. Hopefully the rest of you could hear me okay. Certainly hope so, because I got some questions through. But I know the guys who couldn't hear me probably won't be hearing this, but I am recording this session and we will make a copy of this available to everybody who registered and attended. So hopefully anybody that couldn't hear it will be able to when that gets sent out. Steen says, super audio, smiley face. Oh, that's good. So most of you could hear me. That's excellent. So, all right, I'll wrap up here. I know I've waffled a bit and I've taken a lot of your very valuable time. Please feel free to work with us. Get the software, give it a try. If you even want to just run a quick lab test on a single machine, whether it's a spare laptop that you've got or a workstation or a VM that you want to spin up, we can help you with that as well. I recently wrote a little batch job that will run the software or run a mixed workload of different types of storage IO traffic at a reasonably peak load for an hour, with velocity unable to do anything other than just measure how well that machine performs. So you can see, for example, how much storage traffic that machine could cope with by itself. And then in the second hour, velocity will turn on all of its enhancements and run the same workload. And you'll be able to see how much storage workload that machine could process by itself and how much more it could process when velocity was assisting it. I actually ran that on my workstation here. I was pretty surprised by the results. You know, I've got quite a beefy workstation. I've got 32 gig of RAM, so plenty to cache with, a lot of CPU cores, and I've got an NVMe connected SSD, so that's super fast as well. And by itself, my machine was able to generate and process about 350 gigabytes of storage IO traffic in the first hour. In the second hour, when velocity was able to use its RAM cache, that increased from 350 gig to just a squeak over a terabyte. And the only difference was that we were now using RAM to satisfy a good percentage of that read IO traffic. So if you want to run that as an initial test before putting it on your real machines, let us know and we can provide that to you as well. So I will wrap up there. Sorry for waffling. I do hope it's been interesting. Please let us know how we can help. If you want to tell us a bit about your environments so that we can tailor a conversation around how we think we can help you, let us know, get in touch. And yeah, thank you very much, everybody, for attending today. I hope it's been interesting and have a very good rest of day. Thank you.